Let's work to understand the flow of a fluid through a pipe of a varying cross-section. So it starts with a cross-sectional area of A1, and ends in a cross-sectional area of A2. We have this fluid flowing through the pipe, starting at velocity 1 and ending at some velocity 2. Let's try to figure out what this resulting velocity 2 would be. First, I think we should break out this problem by this section. So this is our tube, has some length L, and same cross-sectional area, A1. Flow rate is the amount of liquid that flows through this length L of pipe over time, and we call that Q. So as I said, just like it sounds, volumetric flow rate, Q is equal to volume over time. When we're thinking about this liquid flowing through this pipe, it has some velocity to it, just like V1 to V2. So velocity equals distance over time, which in this case is L over time. We know that the volume of this tube is the area times the length over time. We can see that is here. So we know that our flow rate is equal to our cross-sectional area times our velocity. Okay, so when we're thinking about this problem, we know that the starting mass has to equal the ending mass per the conservation of mass. We can also then say that the starting flow rate, Q1, has to be equal to the ending flow rate, Q2. Based off the equation we just derived, this looks like A1 times V1, velocity, equals A2 times the resulting velocity. We call this the equation of continuity. And knowing that, we can solve for the resulting velocity from this pipe of varying cross-section.